Hi, my name is Douglas Parker. I'm a sophomore and my final project was a piano MIDI editor that allows you to record and play your songs. So let's go ahead and record something. Gives you a count off. And now we're in record mode. All right, so what do you think of that song? Well, let's go ahead and pause our recording and give it a little listen. Yeah, I think you're right. It's missing a little something. Well, luckily with my program, you can actually re-record over the track as many times as you want to perfect your composition. So let's go ahead and do that. There we go. Now, let's give our full song a nice listen to, shall we? All right, that's my full program. Let's go ahead and get a clean slate and talk about some cool features. So one cool thing is that there's 32 playable notes, but there's only a height of 12 sprites on the MIDI window. So what I did was I actually had each sprite correspond to a 3-bit pattern. So the sprite number 5 corresponds to a note, a blank space, and a note, which is kind of nice. So you may be thinking, why 32 notes? If the height is 12 sprites, you might as well do 36. Well, the reason for that is I completely refactored the sound generator. So instead of being passed in a 32-bit integer representing the period of a note, I pass in a 32-bit integer representing a single slice of the MIDI track, where 0 is off and a 1 means a note is currently being played. And inside the sound generator module, it takes the 32-bit integer and passes it through a daisy chain of 32 to 1 priority encoders, where in between each priority encoder, it masks the highest priority bit in order to extract the position of the 6 highest notes in the MIDI track. So if you were playing 7 notes, it would only play the highest 6. And another cool thing with the priority encoders is they output a valid flag, which we can use to count how many voices actually need to be output. So we would cycle through, let's say, 3 voices that were on, instead of cycling through 6 different channels with only 3 voices active. Another interesting feature is I implemented a get3 key function that allows you to read key presses, key releases, and utility buttons such as pause and clear the track all at the same time. When the user presses a note, the program bit shifts a binary 1 by the index of that key in the character array, and then uses that new value as a mask to OR onto the current MIDI slice. And that way you can press multiple keys to create a chord in the same time instance. On the flip side, if a key release is recorded, it uses an XOR to remove a pressed key from the current slice. The hardest part of this project was I could not get my program to work on the Mars debugger or the project simulator, simply because I think the scope of the key reading was just out of the ability of those 2 simulators. So I had to do all my debugging on the board, which made the process a lot more lengthy, but I think it was a lot more fun actually being able to interact with the real thing and debug it like that. And speaking of having fun, I really enjoyed this project, especially at the end when I got to just play around with the program I made, but also by the end when I thought of new functionality like that clear button, and I was like, oh, I can just whip this up in 5 minutes. I wrote the assembly, and that felt good to just be able to do that. Thank you for watching my video. Hope you enjoy the project.